Hi there. So I'm going to be going through the A-level physics OCR paper. OCR A-level physics A, paper 2, the specimen paper. I've just done this paper and I think I got 86%, I think, which is probably an A star, but there's not a published grade band, it's just a specimen paper. But there's still some things I want to go through and some things that I think someone could have dripped on during this paper. Okay, starting with the multiple choice questions, even though I never would in a real exam, 100% we should do the long answer questions first. Find the density of a wire, student makes following measurements, blah 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 blah. Okay, to carry out percentage uncertainty, immediately just use the fraction function in a calculator. Make sure that any squared functions are multiplied by 2, cubed multiplied by 3, and etc. I should probably say the answers. And that was D. Okay, for 2 copper wires connected across a cell, the conduction electrons within the wire move. What statement is true about the electrons? Okay, well we know that electrons have mean drift velocity. What does that mean? It means that they collide with ions in the metal, which gives them random velocity because of these collisions. And we know that they drift towards the positive terminal because they're negatively charged. Okay, so they drift towards the negative end of the terminal. That is not true. They have random speeds because of collisions with the other electrons. No, that's not true because that's not why they have a random speed. And they probably wouldn't collide with each other because they're going to repel each other. They travel through the wire at the speed of light. No. And they collide with vibrating copper ions. They do because copper is a solid and thereby it's ion splitting. So yeah, the answer is D. 3. A resistor R and an ammeter and a switch connected in series, blah 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 blah. What's the internal resistance of the battery? Immediately we're finding lost volts. Here you can see the difference is going to be 3, and you've even got an ammeter reading, so we can just divide that 6 by 3. No, the 3 by the ammeter reading, so 1.5 is going to be our resistance because it's just the potential difference that's been kind of the power that's been dissipated over this bit, which we know is accountable for that 3 volt difference. Because of course when there's no current, the potential difference is still there, but there's no power dissipated, so yeah. The following is true about photons. All photons travel at the same speed in a vacuum. Yep. All photons don't have any charge. Yes. They don't have any charge. They don't have any mass either. The energy of a photon depends only on its frequency. Yep. So all 3 of those are true. So the answer is A. Okay. Question 5. There are electrons traveling through a thin layer of a metal, and they're diffracted. Electrons travel as a photon through the metal? No, they don't. Important to note. These electrons are diffracted, and so they're acting as a wave. This is their wave duality, and photons are light, constant light particles. Electrons have a wavelength of 10, or we could calculate it, but I think we can calculate it. Electrons are diffracted by holes in the metal. No, they're diffracted by gaps in the metal, so I don't think that's specific matter even. Electrons are heavy to reduce the diffraction, that's just true, so we can remember the answer is okay, sodium lamp is rated at 40 watts, about 12% of that power is emitted as yellow light of wavelength 5.9. Okay. Energy of a photon, hc over lambda. The energy that's going in to produce that is going to be 40 times 0.12, obviously, because that's the useful power. And then, so we can do energy of a photon, N equals the energy that we have here, that 40 times 0.12, which should give you N is equal to A, so 1.45 centimeters, 17 per second. Also, we can ignore that this was in power and what people asked for us in seconds anyway, and then what's is going to be in seconds anyway. 14 volt DC supply is used to charge a car battery for 12 volts and a cell is 8 to 6 hours. How much will it count to provide? How much work can be provided today? How is this price? The first quote so we know that the supply, we don't need to worry about anything lost or there's 12 volts, we just need to know it's like 14 times the current times the time, because she was IT, so 14 times 2.5 times, I'm going to say 6 hours, 6 times 57, 57 hours, which should give you D, 7, 6, and 10, 6, 8, the electric potential is, this is 4.2 centimeters for 4.1 centimeters, 2 minus 5, 4 minus 6, okay, so an electron and an alpha particle, so we know they're going to attract, which means it's potential there, and what's the magnitude is potential, magnitude and immediately means the arc, so it's going to be positive, so we can cross out everything ready. This is the midpoint of the alpha particle and electron. Well, if you look at our formula book, we know that potential is proportional to 1 over r, just 1 over r, so we don't need to worry about it squared. So if it halves, then the potential is just going to double, so our answer should be 4.8, which is C. 2.4, doubled it twice. No need to do that, don't double it twice. It's B, just double it. Okay, a coil with 3 turns of the wire is used in experiment. The glass of magnetic flux linkage with time for the coil was the EMF induced. Right, trick question. Immediately, I think I've done this for a very long time ago, and I remember tricking up on this question because I got confused with whether flux linkage contained that in or not. It does. So if you're already given the flux linkage, ignore the number of terms. So we just need to work out the gradient of this one. So 16 times 16 over 4 times 10 to the minus 3. Which should give you, let's see, yeah, 0.4. Because we don't need to worry about the number of terms. Is there anything else? Oh yeah, I think I forgot that first time. We go 10 to the minus 4 over, but your gross error check should tell you